So when trying to figure out how many radians are in a circle, we're using that idea that since every time we have a radius along the outside, that is 1 radian as measurements. And if you wanted to count how many radiuses are around the whole side, we can use our circumference formula. Our circumference formula basically says there are 2 pi radiuses around the edge of your circle. That's what that formula means. And so when we're trying to figure out, well, if every radius is 1 radian, then that means that there are 2 pi radians in a circle. And that's powerful because we can now use this idea to convert between radians and degrees. Because now we have a way of comparing them. If there are 2 pi radians in a circle, that means that 2 pi radians is equal to 360 degrees. 2 pi isn't equal to 360. 2 pi is 6.28, right? But 2 pi radians is equal to 360 degrees. Let's do some other things like that. Is 12 equal to 1? No. 12 is not equal to 1. But if I add units, I could say, is 12 inches equal to 1 foot? Yes. Is, well, this one's going to be approximately, but 100 kilometers per hour is equal to 60 miles per hour, approximately. They're close. So we have a lot of different things that are not quite equal, but once you add the units, they are equal. 75 cents American is 1 Canadian dollar. It's probably better now. Is it 80 cents? I'm not sure. I haven't traveled to the United States for a bit. But we have different times where different numbers are equal if we add the units. So 2 pi radians is 360 degrees. And then you can just use some proportional reasoning to figure out other ones. For example, if 2 pi radians is equal to 360 degrees, how much is pi radians? 180. And from here, could you figure out, how would you figure out what 1 radian is? 1 radian would be 180 degrees divided by pi. And if we type 180 divided by 3.14 or 180 divided by pi in our calculator, we get a little bit less than 60 degrees, 57.3, which is what we would have expected from our triangle thing that we did at the beginning. If you wanted to find, so I'm going to put a box around this one. 1 radian is 180 degrees over pi. If you wanted to find out what 1 degree was. Again, we're going to use the same idea, sort of starting from here every time, or starting from here. Because if you know 360 degrees is the whole circle and 2 pi from the circumference is how many radians are in the whole circle, then you can figure out pretty easily that pi radians is 180 degrees. If I want to get from 180 to 1 degree, I would have to divide by 180. So I would have to do the same thing. On the other side, so pi over 180 radians is equal to 1 degree. And those two in the green boxes can help you figure out anything. If I wanted to find 5 radians, I could take the first box, multiply both sides by 5. If I wanted to find 5 degrees, I could take the second box, multiply both sides by 5. And 5 degrees is 5 pi over 180. So this will be our way to be able to convert from one to the other. And you don't have to memorize these boxes. Because if you know that there's 2 pi radians is 360 degrees, you can figure out that pi radians is 180. And to go from this one to this one, we divided both sides by pi. Because then pi divided by pi gives me 1 radian. And to go from this one to this one, we just had to divide both sides by 180. Because I take my degree sign, I wanted 1 degree. So if I divide by 180, well, then that gives me pi over 180. So sometimes trying to memorize those, since they're so similar, you mix them up. But I say don't memorize them. If you know that pi radians is 180, you can recreate those easily. And maybe if you use them so much you memorize them, that's fine. But this way you know how to find them. On your next page at the top, whoops, that's not the next page at the top. Oh, it's here underneath my, so I got to erase things here. Gone. On the next page at the top, you have this radian measure. It has what we just figured out, this 1 degree and this 1 radian. It has this important information that we determined as well. I would also like you to write beside this box, you have some space. In the box here, I'll just erase this at the bottom too. Right beside this, what we're going to write down is what we did in our math lab from yesterday. So we're going to rewrite the formula we figured out for our arc length in degrees. Now our arc length in degrees, again, your formula sheet uses S. You see that your textbook uses A for arc length, which seems to make more sense, but we'll use S like our formula sheet. What we figured out yesterday is your arc length is just a percentage of the whole circumference. So if we took whatever angle we had and divided it by 360, that's a percentage of the whole circumference. And then we multiply that by the circumference, we'll get the arc length in degrees. What does this formula look like in radians? Well, it's exactly the same idea. Your arc length in radians, well, you have your angle in radians, but instead of being divided by 360, how many radians are there in the circle? 2 pi. So it's the same formula. And on your formula sheet, because it simplifies so nicely, what happens to the 2's? 2, 2. What happens to the pi's? 2, 2. They cancel out. And so this formula on your formula sheet, because it simplifies so nicely, your arc length is just your angle times by your radius. And that is your first formula on your formula sheet. And as a result, I will hand out your formula sheets now. Here's our first example. Given theta equals 170 degrees, determine its measure in radians. Give the exact measure and the approximate value. So there are some keywords that we're going to need to know here. We're going to need to know what exact measure means. Exact measure means you're not typing something into your calculator and rounding. You're keeping pi, or you're keeping your answer as a fraction of pi. So in A here, if we want to convert 170 degrees to radians, we know that 1 degree is equal to pi over 180 radians. And so to calculate 170 degrees, you would have to multiply both sides by 170. And so 170 degrees is 170 pi over 180. And you could reduce this to 17 pi over 18. You could probably see that the numbers could reduce. However, you can leave fractions unreduced if you would like. Some important notation things. Whenever you're writing an angle with degrees, you need to have the degree symbol. That indicates that the angle's in degrees. Whenever you write an angle in radians, there is no symbol. There is no units that are written. I've written radians so far just to get used to it, but this is all you would need to write, 170 pi over 180, and whenever you're talking about an angle and no units are given, it is assumed to be in radians. So it's very important that you have degree signs with degrees and you don't need any symbols with the radians. So if we wanted to find the approximate value, then we would take out our calculator and type it in. And this is approximately 2.97 radians. Part B, given theta is negative 12 pi over 11, sketch the angle in standard position and determine its measure to the nearest tenth of the degree. So when sketching this angle in standard position, well, we know that it's going to start on the positive x-axis. And we know that the angle is negative, so it's going to be going clockwise, starting from the positive x-axis. How do I determine where negative 12 pi over 11 is? Well, how did I know it's going to end here? For one, I've had a lot more practice than you. But let's think about what the whole circle means in radians. And this is something that you're going to know very well by the end of the year. I'll do it in the positive direction, but if this is 0 radians, it's also 0 degrees, if you went all the way around, it would also be coterminal with 2 pi radians because it's coterminal with 360 degrees. Halfway around, I don't like how that's written. I'm going to rewrite that. So this is 0 or 2 pi right there. If you went halfway around, does that make sense that that would be pi radians? And 90 degrees would be half of pi, or pi over 2. And 270 degrees would be like 390 degrees, or 3 pi over 2. So when I'm looking at negative 12 over 11, if I just look at the numbers 12 over 11, does that make sense that that's more than 1? In fact, I can write this as a mixed fraction as negative 1 and 1/11 pi. So I need to go more than 1 pi and just an 11th more. So when I drew my diagram, halfway would be pi. And then I needed to go another 11th more. Maybe mine is a little bit big. If you imagine from here to here divided into 11 equal sections, you just need to go 1/11th more. So does that make sense how I could come to draw this angle in standard position? I need to go in the negative direction. I need to go a little bit more than pi. So I need to go more than half and just 1/11th more. determine its measure to the nearest tenth of a degree. So here, since we know that 1 radian is equal to 180 over pi degrees, if we wanted to find 170 pi, or sorry, no, negative 11, negative, what was it, 12 over 11 pi? Is that what it was? Double check, yes. If I wanted to find that in degrees, well, from here to here, I've multiplied by a negative 11, sorry, negative 12 pi over 11. That's what I've multiplied by. So I would have to do the same thing over here. I would take my 180 degrees over pi, and I would have to multiply by negative 12 pi over 11. One thing that's nice is your pi's will cancel out. If we type this into our calculator, to the nearest tenth, this is negative 196.4 degrees. Does that match up with the diagram that we've shown? Does our diagram look like 196 in the negative direction? Yes. One thing that you're going to find that you can use as a shortcut when changing from radians to degrees, because you know that pi radians is equal to 180 degrees. And again, I'm just going to keep writing radian for now, because too often, too early, people start to think that pi equals 180. It doesn't. 3.14 is pi. Last time I checked, 3.14 is not equal to 180. If it does, I'll give you $3.14, and you can give me $180 back. If you believe that, perfect. I'll make a lot of money, supplement my teaching salary wonderfully, and I'll go on trips to Mexico. But pi radians is 180 degrees, so as a shortcut, if we want to change negative 12 pi over 11, all we need to do to change it is change the pi to 180 degrees, and that will get us quicker. If we look at what we did mathematically, can you see that the pi disappeared in the negative 12 over 11, and then you multiplied by 180? So as a shortcut, if you're changing from radians to degrees and it has a pi, you can just change that pi to 180 degrees and simplify from there. That makes your life a lot easier. Part C, given theta is 7.5 radians, there's no pi in this one. Determine this measure to the nearest tenth of a degree. So again, we know that 1 radian is equal to 180 over pi degrees. So if we wanted to find out what 7.5 radians is, we would have to multiply this side by 7.5. Type that into our calculator. And we get 429.7 degrees. Questions for practice are 4, 5, and 7.